perfect squares and square roots. Here we have a list of what we call perfect squares. If you look at them, you'll see that they are perfect squares. They have the same number of dots for the length and for the height. And so each square could also be called an array. So this one is a 2 by 2 array, 2 by 2. This is a 3 by 3 array, a 4 by 4 array, a 5 by 5 array, and a 6 by 6 array. This should bring you back to your earlier years of schooling when you learned how to multiply. When you multiply two numbers, you can draw out an array and count up all the dots to find your answer. So 4 times 4 is 16. And if we counted the dots in here, we would find that there were 16 dots. Same with 3 times 3 is 9. So this is one way to model multiplication. So what makes these perfect squares? Well, a perfect square will have the same exact numbers along the bottom, the length, and the height of the square. And if you notice, it makes a perfect square. And so this square is a 4 by 4. We already said that 4 times 4 equals 16. All of our perfect squares are represented when we multiply one number by the same number. So 6 is a perfect square. This is an example of another perfect square. We have 5 by 5. 5 times 5 equals 25. 25 is also a perfect square. As we continue, we can do 6 by 6, which equals 36. Another perfect square. Anytime you have two of the same numbers multiplied by each other, there is a simpler way to write this, and that is saying squaring a number. And if you think back to our perfect squares, where it's the same number along the length and the same number along the height, we're multiplying by the same number. And you can write that as 5 squared, which represents 5 times 5, which equals 25. 7 times 7 can be written as 7 squared. Think about when you're finding area, you are squaring, you're finding the square units. And this equals 49. Here I have listed out the perfect squares that go up to 144. And for each one, you should be able to figure out what the two factors are that are multiplied by each other to get that perfect square. So 4 is 2 times 2. 9, 3 times 3. 16, 4 times 4. 25, 5 times 5. 36, 6 times 6. 49, 7 times 7. 64, 8 times 8. 81, 9 times 9. 100 is 10 times 10. 121 is 11 times 11. And 144 is 12 times 12. When you're looking at these factors here, you can also think of an array, which we saw in the beginning, that had the dots, the same amount of dots for the length and the width. You may be asked to find the square root of a number, and that is symbolized by this symbol over here, which is called a radical sign. When you see a radical sign over a number, it's asking you what is the square root of that number. So this is saying, what is the square root of 4? Since we see the word square in it, that should make us think of our square numbers. So since 4 is a square number, what two factors when multiplied together would equal 4? And we know that that is 2 times 2. So the square root of 4 equals 2. And here we have all our perfect squares listed again. So let's try to figure out what the square root of each perfect square is. So the square root of 4 is 2. The square root of 9. What two numbers when multiplied together equal 9? That is 3. Square root of 16 is 4. And there are all of your square roots. So here are the things to remember. Perfect squares are when you multiply the same number by itself. So 3 times 3 equals 9. 9 is our perfect square. You can also write perfect squares. Instead of writing the digits twice, you can write it one time with the squared symbol. And that represents 3 times 3, which also will still equal 9 as our perfect square. To find the square root of a number, you are going to use the radical sign. When you see the radical sign over a number, it's asking you what two numbers, when multiplied together, equals 16. Remember, since it's square, it has to be two of the same numbers. So this answer would be 4 times 4, or what we'd write for our actual answer is just 4. Here are some on your own problems.